everyone, I welcome you to yet another lecture under Concept Clarity series with Clarity for Sure, an Agriclarity platform. And today's topic of discussion is soil water. So yes, let's just start with our today's topic. So we know that in soil we have 25 percentage of air and 25 percentage of water. So this is the water we are talking about. This is the soil water. And this soil water could be present in the micropores or it could be present in the macro. That these are large, these are small. Okay. So the one which is present in the micropores are held tightly and are used or could be used by the roots in the longer term because they are held tightly, they are retained by those soil particles. But the one which is held in the macro, that is larger spores, will be drained out eventually. So the one which is present in the micro, that is the small one, is of more interest to us than the macro. So what is soil water? Soil water is the water which is present in the pore spaces of the soil that is available for the plant use or retained by those soil particles through the adhesion and cohesion. Okay, and it's essential for the plant growth because it acts as a solvent for different minerals and also important from the biochemical perspective. Okay, it has role to play in different biochemical reactions and act as a medium for nutrient transfer. So yes, this is about the soil water, the introduction of the soil water. And today's discussion we are going to see the different classification, the physical, biological, and there is one concept of soil moisture constants. So yes, these are the things we are going to discuss today. So let's just start with our physical classification of soil water. Under physical classification, we have three subheadings. Okay, first is the gravitational, second is the capillary, and third one is the hygroscopic. So yes, let's just start with gravitational water first. So the name is only indicating that the force of gravity is acting on the water that is present in the soil. So yes, it moves down. We know if something is if the gravity is acting on it, it is going to move down. So this water is moving down in the downward direction because the force of gravity is acting on it, and it is easily moved because it is present in the macro, that is the large pore space. Okay, and the water which is drained out is called as a drainage water, and of course it is drained out, so it is not useful for the plant because it is not retained for too long. And the pressure, the soil moisture tension. Okay, first, what is soil moisture tension? It is the force, it is the force with which the water is held by those soil particles. Okay, and the force with which this water is held in the gravitational water case is the low. It is as low as 0 or it could be minus 1 by 3 bars. So because it is held too loosely, it is going to get drained out under the force of gravitational, okay, and it is not available for the plant. And yes, this is what is the gravity. So how we can link things in here. Okay, the name is only indicating the force of gravity is acting. Because of it, it is going to move downward. Okay, and it is going to get drained out. Along with drainage of water, there is also leaching of nutrients. Okay, as we said, it acts as a solvent. The nutrients are going to get mixed up with that water and will be leached out, which is not beneficial for us. Okay, we don't want leaching of nutrients. So the drainage of water and the leaching of nutrients is happening. As it is easily drained out, it must be present in the macro, the larger pores. Okay, it is present in the larger pores. And if it is easily drained out, means it must be held with a low soil moisture tension, as low as 0 or could be minus 1 by 3. So, yes, I hope the point is clear here. The next one is the capillary water. You can see here capillary water, it is held in the micro, that these are small pores, and is available for the plant because it is held for longer period by this soil particles. So yes, what is capillary water? Capillary water is held in the micropores that is also called as a capillary force against the gravity. What does mean against the gravity? That it can move even upward, okay? It can move even upward. And the field and it is present between the field capacity of minus 1 by 3 to hygroscopic coefficient of minus 1 31, okay, minus 30. So yes, but the force of retention of water molecules by the soil particle is high and part, so because of this, the part of water is available and the part of water is unavailable, okay. So the entire capillary water is not available. There is a division, okay. Let's discuss that division. So we have outer capillary water and we have inner capillary water. So the outer capillary water is held with minus 1 by 3 to minus 15 bars pressure and is most useful water for the plants, and is because of that it is called as available water. But the inner capillary water is unavailable because it is held tightly as compared to the outer capillary water, that is minus 15 to minus 31. So just let me just clear this. So consider these are the two soil particles, okay. So the inner capillary water will be near to this soil particle, okay. This is inner capillary water and this is outer capillary water. So what do you think will be available? And these will be the roots of plant, right? So what do you think is available to the root? So the answer should be this blue part, that is outer capillary water, right? So outer capillary is loosely held and inner capillary is tightly held. So the one which is loosely held, that is outer capillary water, is available to the plant. Okay. So this is about the capillary water. Next one is the hygroscopic water. So we covered gravitational water, we covered capillary water. This is hygroscopic. We see in gravitation is loosely held as loose as zero pressure. Capillary is kind of medium. It is good. It is not that loose, not that tightly held by the soil particles. That is around minus 1 by 3 to minus 31. But again, the outer one is available and the inner one is not. Okay. And the hygroscopic is like this. This is extreme end and this is the right extreme end. Okay. This is tightly held by the soil particles. So you can see here it is held tightly on the surface of soil. You can see here, and and the term which is used for this water is called as hygroscopic water. It is essentially non-liquid, so because of that it is inactive and it is mostly in the form of vapors. Okay, please note it down. They can ask which of the following soil water is present in the vapor form. So it is the hygroscopic water. Okay, and because of that it is unavailable to plant. This gravitational water is unavailable. This is unavailable to the crops. Okay, and as it is tightly held, the pressure is too high as minus 31 to 10,000 bars. Okay, so yes, I hope the points are clear. The gravitational water will be drained out easily because the zero soil moisture tension is there. Hygroscopic water is too tightly held and it will not be available. It is there, it is present around those soil particles, but the crops cannot absorb it because it is held tightly and the crops don't have that much energy to absorb that particle from the surface of soil. Okay, but the capillary water and more specifically outer capillary water is optimally held. The energy which is present with the roots or the crop, that energy can be used to utilize this water which is present between the micropores. Okay, so yes, this is what is the gravitational, capillary, and hygroscopic classification of water. Next, after physical classification, we are going to discuss the biological classification of cell. Okay. So, under biological, we have three headings: available water, unavailable water, and super available or superfluous water. We already covered this. Um, it is just will be the revision. Okay. So you only tell me the available water should be what? It should be the part of capillary water. The capillary water was what? So it was the water which was present between the field capacity and the wilting point. You will be clear after we are going to see the soil moisture constant. But yes, for now let's keep in mind the part of capillary water is available water. Okay. Next is unavailable water. You can see here, right? Available water. The next is unavailable water. It should be water which is it is there, but it is not. The roots cannot extract it, right? The water is called as hygroscopic water, okay? And some part of the capillary water, which is below wilting point. That is inner capillary water, right? It is outer capillary water is present. And the next one is the super available or superfluous. That is, it is too much, it is extra, it is going to drain out, right? That is the gravitational water. So yes, this is the saturated condition, means the water maximum amount of water that can be held by a particular soil. So this will be gravitational water. The available will be which is part of field capacity or the capillary water, and the unavailable, that is the hygroscopic water. Okay, so this is the biological classification: available, unavailable, and super available or superfluous. Okay, to discuss the soil moisture constants. Okay, so this is the last concept for today. So soil moisture constants are the specific moisture levels which is significant for the overall growth and development of crop. Okay, so the first one is the field capacity. So field, okay. After we apply the irrigation of water to fields, the water will be, as I said, water will be present in the macro or micro, but it will drain out eventually, and the water in the micro will remain in the soil for the longer term. So the field capacity is the point where the water which was present in these larger pores will be drained out, and the water is now only present in the micro pores. Okay, so let's discuss the field capacity or see the definition of field capacity. It is the water held in the large pores moves down, while the water which is held in the micro pores is retained against the gravitational force. And this is the soil moisture held by the soil against, so the field capacity is the soil moisture which is held by the soil against the gravitational force, and this is what is called as a field capacity. Okay, the at the field capacity, the micropores are filled with the air and the micropores are filled with the water. So there is a equal or the balanced combination of water and air present in the soil, which is beneficial, which is the ideal condition we want. Okay. So yes, the energy status of soil at the field capacity is minus uh, 0.33 bars, and the field capacity is considered as the upper limit of water availability. If the water is available beyond the field capacity, it will be considered as extra. We don't need this. Only the water which is present till the field capacity will be absorbed by absorbed by the roots, and whichever is higher, that will be extra. We don't need that. Okay, even if we are irrigating till the fill capacity, the yield will be good, it will be optimum. Okay, so yes, this is the upper limit of water availability to the plants. And yes, so the second soil moisture constant is a permanent wilting point in field. This sunflower crop is used as an indicator for the PWP, that is permanent wilting point. It will start when the soil moisture reaches this permanent wilting point. It will start to show the sign of wilting, and that time you need to apply. It is the high time for you to apply the irrigation, because if it is further going to reduce below the wilting point, the plant will not recover even if you apply the irrigation. Okay, so it is a high time. It is the lower limit of the water availability below which the water will not be available to your crop. Okay, so yes, the soil moisture content at minus 15 bars is referred to as a permanent wilting point. At this moisture level, plants will start to show the signs of wilting, but will not die. Okay, it will not die and are able to absorb small quantity of water, just sufficient for their survival. And plants can recover if the water is applied supplied at this point. Okay, and it is considered as a lower limit of water availability to the plants. So yes, it started showing signs of wilting, but it do not die. It will it is taking water sufficient for their survival. So even if you apply water at this point of time, there are a chances that your crop will survive. Okay, so this is the lower limit, and the field capacity was the higher limit. Okay, it was a higher limit, and this is the lower limit. Below this, crop will not survive, and above this, there is a extra water that we don't need. Okay, so yes. And the last one is the ultimate wilting point. The soil moisture tension at this is as high as minus 60 bars. You can imagine this is so high that water is not available to plant and they will die. Okay. In this, it was showing signs of wilting, but not died. Here it is died, and there is no chances that your crop is going to recover even if you apply the irrigation water because of this high soil moisture tension that is developed. Okay, and this is the point which is called as the ultimate wilting point. So this is the upper limit, this is the lower limit, and we want to keep our soil moisture in between this range because it is safe. Okay, this and because it is safe, it is called as available water. We covered this in this point, right? Available water is the water which is present between the field capacity and the wilting coefficient. This was the point. Okay. So yes, this is it about today's. These are the two practice MCQs. Please solve these. And in today's discussion, we covered the physical classification of soil water. Second, we covered biological classification of soil water. And third was the soil moisture constant. These are the three concepts we covered in today's discussion. Thank you for watching and see you in the next session.